Welcome students. So we were discussing some numerical problems from the chapter machines. The problems have been taken from Conscience Physics book class 10 SSC. Okay. So what does the first problem here has been said? A fixed pulley is driven by a 100 kg mass falling at a rate of 8 meter in 4 seconds, and it leaves a load of 75 kg. So from the given information you can say that the effort is actually applied by that 100 kg mass, and it has been given that the 1 kg force of gravity on 1 kg mass is 10 newton. So first of all, let us write the given informations. So we are solving number 1, solution 1. Okay, so from this we can say on the given information what we can write is, so given is mass driving the load, mass driving the pulley. What it is given, it is given as 100 kg. Okay, so you can write that as it is driving the pulley, definitely you can write that effort will be equal to 100 into 10, that is equals to 1000 newton, isn't it? Why we are writing it as 1000 newton? Because it has been given in the problem that the force of gravity on a mass of 1 kg is how much? 10 newton. It is given here, isn't it? 10 newton. So the effort actually is 100 into 10, that is 1000 newton, and the effort is moving at a rate of 8 meter in 4 seconds. So can we say that the velocity of the effort, we can write it as how much? For 8 meter in 4 seconds, so 8 by 4, that is equal to 2 meter per second. Okay, so this is the velocity of the effort. So, and the load has been given as 75 kgf. So if I convert this kgf into newton, it will be 75 into 10, that is equal to 750 newton. Okay, 750 newton. Fine. Now what is the first part of the problem? Power input to the pulley taking the force of gravity on 1 kg as 10 newton. So first of all, we have to calculate the power input. So I think in the previous chapter we have obtained one formula for power, that is power equals to force into velocity, isn't it? So here the force due to the effort is how much? 1000 newton. So coming to the first part of the solution, so power input will be given as effort into velocity of the effort. So we are utilizing the formula power equals to force into velocity. So power input equals to effort, this is the force, into velocity of effort. So velocity of effort. Okay, fine. We have utilized the formula here. Power P equals to force A into velocity V. We have utilized this formula. Okay, fine. So now, so what will be the value here? The value will be something like this. So effort is actually 1000 into velocity is 2, hence it becomes 2000 watt, or you can say 2 kilowatt. Okay, so this is the first part of the problem. Fine. The second part of the problem, what does the second part of the problem has been asked? The efficiency of the pulley. So first of all, for getting the efficiency, we have to calculate the how can we get the efficiency? We can get the efficiency by calculating the input power and output power, isn't it? Okay, so if I consider the input power and output power, so what will be the value of input power and output? Input power we have already obtained as 2000 newton. So what will be the value of the output power? Let us see. Okay, so that is also another way to calculate the efficiency. You know that for calculating efficiency you can also use another formula. We know that mechanical advantage of a machine is equal to velocity ratio into efficiency. Or you can also write this as, this implies that efficiency is equals to mechanical advantage by velocity ratio. Now what is the value of the mechanical advantage? See, the value of the mechanical advantage here will be, how will be the mechanical advantage calculated? So you know that mechanical advantage is equal to the load by effort. So load, I think, is given as 75 kg, isn't it? 75 kg, and the effort is given as how much? 1000 Newton. So if I just convert that 75 kg into Newton, it turns out to be 750 Newton. By effort is 1000 Newton. So this turns out to be 0.75. Now for a single fixed pulley, we can, I can easily write that for single fixed pulley, the value of the velocity ratio is always equal to 1, for a single fixed pulley. For a single fixed pulley. In ideal case, for a single fixed pulley, value of mechanical advantage is also equal to 1. But as this is not an ideal pulley, so the mechanical advantage turns out to be 0.75. Hence, we can write that efficiency is equals to 0.75 by 1, that is equals to 0.75. Or you can also write as that, therefore efficiency is equals to 0.75, or it can be also written as 75 percentage. Okay, this can be also written. So this is the efficiency of the pulley. Now the third part of the problem, height to is the load is raised in 4 seconds. Now in a pulley, in a single fixed pulley, we know that the distance moved by the effort and the distance moved by the load are the same. So as the distance moved by the effort is equal to the distance moved by the load in a certain specified time, hence the effort moves by a distance of 8 meter in 4 seconds. Hence the load will also move by a distance of 8 meter in 4 seconds. Therefore our required answer is distance moved by the load is also equals to 8 meter, because the time has been asked as 4 seconds only. So 4 seconds. So definitely the answer will be 8 meter. Okay, so the solution, I think, is clear. So this was a conceptual problem. You must have clear understanding of the concept, only then it will be easier for you to solve the problem. Okay, now quickly moving on to the solution number 2. What does the solution second problem says? Let us quickly just go through the problem. What is the given problem here? It doesn't say the block and tackle system has 5 pulleys. If an effort of 1000 Newton is needed in a downward direction to raise the load of 450 Newton. So effort has been given, load has been given, number of pulleys has been given. Okay, so first of all, just let us write the given informations. The given informations has been given here. Okay, so what are the given informations? Given information is that value of load is given. How much it is given? Value of load. Load is 4500 Newton and effort is 1000. 4500 Newton. Effort is given as 1000 Newton. Okay, load 4500 Newton and effort as 1000 Newton. Okay, fine. What else has been given? Let us see. Okay, again it has been given that number of pulleys is 5 in the block and tackle system. So number of pulleys is 5. Number of pulleys is given as 5. This is equals to n. This is equals to load L. This is equals to effort capital E. So first question has been said that what is the value of the mechanical advantage. Second is velocity ratio. So first part, mechanical advantage, we can write it as load by effort. So load is 4500 by how much effort has been applied. The effort has been given as 1000. Okay, so 2 zeros cuts and the answer turns out to be 4.5. Mechanical advantage will have no unit as it's a ratio of two similar quantities. Second part, velocity ratio. We can calculate velocity ratio from the given number of pulleys. It is equals to n, and that is equals to 5. Okay, And the last part of the problem, what does the last part of the problem says? Last part of the efficiency of the system. So what is the efficiency of the system? Just let us consider what is the efficiency of the system. Efficiency of the system, so eta will be given as we have discussed from the previous question. Efficiency equals to ma by vr. So ma is 4.5 by vr is 5. This turns out to be 0.9, or simply we can write it as 90 percentage. So this is our solution. Okay, so I think that two problems are clear to all of you. So we will be ending our class here. In the next class we will again solve some numerical problems, and hopefully we will end the chapter machines. Okay, so till then, goodbye.